everyone, welcome to another stream, another session. Today we have a special session. It's me and the only one, Jarno Baselier, if I announce it correctly in English.
Yes, you did a pretty good job. Thank you very much. Welcome everybody. Thank you for having me, Melvin.
Yeah, thank you for doing this together. Yeah, for those who are watching, we will start with Jarno talking about Active Directory, as that came out of the voting that he did. And I will talk about stack-based overflow. Yeah, I was first thinking about egg hunters, but I was thinking perhaps better to start with the basics first, so stack-based, then the rest. So, yeah, just I think we can just start, and yeah, so I give the audience to Jarno.
Thank you. Okay, yes, Active Directory is what we're going to talk about tonight. I think almost everybody here will know Active Directory, but let me do a short introduction of Active Directory, and when we're done with the introduction, we are going to take a look at a virtual machine from Hack the Box that has a few vulnerabilities in it. It's of course an Active Directory environment, and we are going to do some basics tonight, and I hope you learned something along the way. So yeah, I think an hour is too short to cover all the things we can do with Active Directory, but at least we'll make a start. Maybe next session we can discuss some other more advanced topics, but today we'll cover some of the basics. And at first I wanted to do Dante, a prolab, to clarify some things, but it's not allowed by the Hack the Box policies to stream an active prolab. So instead we will use an already retired machine called Sauna. Active Directory is actually a database together with a set of services. And the database in Active Directory is called ntds.dit. Let me type that. This is what the Active Directory database is called. And the database is stored on all Active Directory controllers in the system root ntds folder. The database and the services ensure that users can authenticate, and that when successfully authenticated, they receive the correct privileges on a Windows domain, so they can access the resources that are intended for them. The Active Directory database or directory contains, among other things, the users and computers which are present in the Active Directory domain and all the privileges that belong to those objects. All objects, such as users, account, and computer accounts, consist of different attributes, such as a job title, a phone number, and of course the password of the users. The Active Directory services provide different functionalities like authentication and connections between different resources. When multiple domains are connected with each other, we call this a forest. And all the rules that are in place to create Active Directory objects are defined in the so-called Active Directory schema. Objects themselves are created in the Active Directory database and organized in a tree-like structure. Objects are stored in folders we call OUs, or organizational units. And all the things I'm talking about now, we are going to see later on in the stream, in the machine. OUs can have child items, and that's how the tree-like structure is formed. When Active Directory is created, at first, the basic structure, including OUs, users, and properties, is already created, of course, in a basic setup. And it's up to the Active Directory administrators to design Active Directory as a solid, expandable, clear, and secure resource. With configuration and legacy, security issues will eventually be created or formed, and when they do, attackers will take advantage of them. Because Active Directory is used by the majority of companies, ranging from small to enterprise, it's important that red teamers test the security at least on a yearly basis. Some of the basics, well, we are going to do them right now. So let's start with the Hack the Box Sauna machine. And I already started the machine, so we do not have to wait on that. And please let me know if you have any questions. or if I need to clarify the things I'm currently doing. I might not be able to answer all the questions, but at least I'll do my best. Melvin, I do not see the questions, so when there are questions, please interrupt and ask them to me.
Yes,
if that's okay with you. Cool. So we have a machine listening at an IP address. The IP address is 10.10.10.175. And that's all we know for now. So let's create a basic structure. And usually I'll do it like this. We're going to make some directory, make dir. And we are going to make the directory Sauna. And in Sauna, we are going to create a scans and a loot directory. Like this. At least I thought. Make dir Sauna on the desktop. Yes, that was almost correct. I forgot the /. Now it works. Cool. And the first thing we are going to do, as we almost always do with every machine, is to make an Nmap scan. So we're going to do an Nmap. I will use SC for enumerating the services, and I'm going to use SV for enumerating the version information. I want to have a verbose output, but I also want to output all the formats like this. And we are going to name the files something like this, Nmap common, and then we are going to scan the first 1000 ports of 10.10.10.175. And this shouldn't take very long. Because we have a verbose output, we are seeing already a lot of ports open. We are seeing port 53, which is DNS. Port 88, which is Kerberos. 389, which is LDAP. And that makes me think we are talking to a domain controller. But let's wait until the scan finishes. Well, while it runs, we already have a port 80 open, which means a web services is listening on this port. So let's check 10.10.10.175. And yes, indeed, we have a website, Egotistical Bank. And what can we do here? We have some text, we have some images. Not that interesting at the moment. We have a newsletter. At least this is an input field, so maybe we can do something with it. We can take a look at the source code if we want. We have a lot of clients. I remember that when I first played this box many times ago, those were names actually. So I remember them because I noted all the names and I used them in enumeration later on. But well, I think because it's a retired machine now, the names are gone and they're just clients. And we have a contact form. What we can try at the contact form is to try some basic cross-site scripting. And for the cross-site scripting, we can use script, alert, alert. And what we're gonna alert, we are gonna say, okay, cross-site scripting, whatever. Like this. And if we would have a cross-site scripting vulnerability, we would receive a pop-up saying XSS, an email address, right? Like this. And the funny thing is with the website is that every time we will input some information inside of a form and the newsletter alike, we will receive a 405 HTTP verb use to exit this page is not allowed, meaning we cannot do anything with those forms. They are malfunctioning. So we have to take a look beyond that. Nmap is ready. So this gives us a nice result of all the open ports. Like we said, DNS, port 80 as a web service, Kerberos. We have LDAP open, telling us the domain name is egotisticalbank.local. It tells me it's local 0, but that's unlikely because, well, in theory it could work, but we almost never see the 0 at the end of the local. Here also. And what is this? We have SMB information, message signing enabled and required, SMB 3.1. And that's about all the information that we have. Okay, and we already figured out that there is not much we can do on the website. Of course, we can do some broader enumeration, but at this moment, we do not have to touch the website. So what more can we find? The next thing we usually do is to run a directory scan to see if there are hidden directories on the machine that we might be able to access. And we can use a wide range of tools for that, but I'll usually use GoBuster or Ffuf. And now let's use Ffuf. And this is nice. Let me see. This is not completely correct. But the W parameter to specify the word list we are going to use. And I think the word list that I want to use is in user share word list. Yes, it is. In the Dirbuster directory. And it's the directory list 2.3 medium. URL we are going to scan. Let me specify the URL by specifying the URL in my host file. So I'm going to connect the IP address that we are currently using, and I'm going to tell my machine that when I tell the machine to go to a specific host name, it will redirect that to 10.10.10.175. Sudo nano etc hosts. And 10.10.10.175 is going to listen on, what was it? Egotistical bank.local. I think this is correct. So now we have that. Let's specify HTTP egotistical bank.local. And we want to see if there are hidden directories behind this. So we're going to fuss behind the dash. And we also want to save this as a Ffuf scan, Ffuf default Dirscan. And let's see what happens. While this runs, we already had SMB open. So maybe we can do some interesting things by enumerating SMB. And for that, we can use a tool called SMB client. Let's try that here and make it a little bit bigger. SMB client. -L just to show us if there are any open SMB shares at the moment. I'm not going to enter the password, so we're going to make an anonymous connection. And anonymous login is successful, but at the moment, we do not have any shares we can use. So, bummer, what more do we have? I thought we also had DNS open. So maybe we can do something with DNS. Let's try to enumerate DNS. Let's see if maybe a DNS zone transfer is possible so we can get all the DNS information that we need. Or maybe we can gather some individual DNS information. And for that, we can also use a wider range of tools. And I'm going to use DNS enum because it's the most easy tool to use. And as a DNS server, I want him to use 10.10.10.175 because if I'm going to use my own public DNS server, it's never going to find the domain. And the domain we want to scan is egotistical bank.local. And let's see if we find anything. That was pretty fast. A zone transfer is not possible. Bummer. But at least we learned the name server is called sauna.egotistical-bank.local. So let's also add this into our host file. And at the moment, it is busy brute forcing the possible DNS entries with a DNS list.
I'm not going to... Oh, sorry. I have
no problem.
One question from the audience.
Yes.
Can you explain more about what are zone transfers and what are you actually doing when trying to do a zone transfer?
Yes, sometimes when DNS is not properly configured, and we usually see this when someone purchases a domain name from somebody else, the domain name has to be transferred to a new host. And at that moment, the lock is removed from the DNS zone, meaning that the holder of the new name can transfer all the information and the name to its own resources. And when the lock is removed, a DNS zone transfer is possible, meaning that if that is possible, I can enumerate all the DNS records that are available inside the DNS configuration. So, with other words, if a zone transfer would have been possible, I would have gotten a lot of information from the DNS. Well, now it's not, so I am only getting some basic information. That's actually why we would like to see a zone transfer to be possible. Like I was saying, at the moment, it is brute forcing more names, but I'm not going to wait on that because I know it's not going to find something. Sudo nano etc host. And we are going to add sauna.egotistical-bank to the host file. So we might use it later on. We've also seen that LDAP is available for interaction. LDAP is listening on port 389. Well, that's plain text LDAP. We also have secure LDAP that is listening on port 636. And LDAP stands for the Lightweight Directory Access Protocol and is therefore a protocol. Keep that in mind. The protocol does not determine how a particular application handles or implements that protocol. LDAP works with a specific structure to store and search information. Very basic information is stored in a tree-like structure. The LDAP protocol works with several data models that describe what type of information is contained in the LDAP directory. Another typical part of LDAP is the use of distinguished names or DNs, which are actually unique identifiers for each entry. Active Directory uses LDAP and the LDAP structure to store information and organize IT assets within an organization. Active Directory is a Microsoft product and uses LDAP, but LDAP is not a Microsoft protocol, nor is LDAP the same as Active Directory. So it's a good thing to know the difference between both, because usually when we're talking LDAP, we are also talking about Active Directory, or we are meaning Active Directory, but it's not always the same thing. Since we know this is a domain controller with Active Directory, we can try to enumerate Active Directory over the LDAP protocol. This way, we might be able to obtain information about certain objects in Active Directory. And like with everything, we also have some tooling for that. Let me remove the split screen because maybe it's a little bit small to read. And let me open a new tab. Like this. And to enumerate LDAP, we are going to use LDAP search. Like this. We're using -X, which is a simple or anonymous authentication. We do not have credentials, so we have to use anonymous authentication. We will specify the host, which is still this one. And we will use -S to set the scope, and we will make the scope as base because we want to know what root LDAP objects might be available. And I will show you this in a bit in the demo. Let me show it right now. I think it's a good moment to do. So this is just another demo machine. It's a Windows server containing Active Directory. It's my own server. So it makes it a little bit easier to show things like this. And like you see, we have Active Directory available. And currently, I am starting the Active Directory users and computers module, which is the module that is mostly used by administrators. And in this module, we can see the structure of the tree of the LDAP tree of Active Directory. And the thing that stands out besides the default configuration is we created a department A with some sub-OUs or organizational units, computers, group servers, etc. When we take a look at LDAP with the LDAP browser, this is just one of the tools available to navigate through LDAP. We can open up the connection to our local host, to ourselves, and down here we will see a bunch of root records on LDAP, where this one is actually, well, all of them are used by Active Directory, but when we are navigating through the users and computers, we are actually navigating through this root record. And down here we will see a lot of the things we just saw. We also have department A with all the sub-OUs and properties or objects that are in there. So, like I said, we are going to enumerate those base records. Let me close this up and switch back to my Kali machine. And we will specify -S as base naming context. Naming context. I think this is right. Let me see what it does. And yes, it does. So this is the output, and this is where we see all the root records of LDAP. And we can also see the base address of Active Directory. That is this one. So since we know the base, we can enumerate from that base and downward. Remember, it's a tree-like structure, so we can enumerate from the top to the bottom. And we are again going to use LDAP search, still -X because we are anonymous. But now we have the base address. So we will specify that by using -B. Copy this, paste. Let's see what we will get. As you can see, it is pretty fast. And this gives us quite a lot of output. We are seeing a lot of objects and settings of Active Directory. Let me see if there are some interesting things here. At least we know there is a minimum password length required of 7 characters. domain controllers OU. Well, that's very normal. Until now, it looks like a basic Active Directory. One thing that stands out is this one. We have a user called Hugo Smith. So maybe let's make a note of that, because we can't do anything with this information at the moment, but maybe later on. So like this. And I think there is nothing more here for us. We can also see the directory scan is finished, and it gives a lot of nasty output that I really didn't want to see. I have no idea why it tells me the progress. And I have lost my scroll bar to go to the top. Page up doesn't work, so that's, well.
It's on the right side.
Yeah, I know it should be on the right side, but because of the screen sharing that I'm currently doing, there is a border on the right side, and it completely, I cannot see the scroll bar. Well, whatever. Minor technical issues. If I would scroll all the way to the top, I would see that we would have found no interesting directories on the website whatsoever where we can do anything with it. So I did the directory scan as an example of what I would usually do when I would encounter a website like this. In this case, it's absolutely useless. So let's continue. We found a user called Hugo Smith, and that's all we have. What more can we do at this moment? We might be able to take a look at Kerberos. Remember, Kerberos was listening on port 88. And Kerberos is a computer network security protocol which authenticates access to services between two or more trusted hosts within trusted and untrusted networks, such as the internet. Kerberos is also the default authentication service for Active Directory. Kerberos uses tickets to allow or deny access, and these tickets are verified with a trusted third party, the so-called KDC or Key Distribution Center. Kerberos is the default authentication method for many services, such as web services and single sign-on services. Because of Active Directory, Kerberos is common within Windows networks. But there are also Kerberos implementations for other operating systems, such as Apple and Linux. Like I said, Kerberos is an authentication method, and at the moment we do not have any credentials. Well, if we do not have any credentials, then what can we do with Kerberos? One method we can try is an anonymous user. As an anonymous user is to brute force the usernames, because valid users can request ticket granting tickets or TGTs, and non-existing users cannot. We can use this knowledge to check the return message when we request the tickets. The return message of a valid user is different than the return message of a non-valid user. This way we can enumerate at least some valid users. So let's do some brute forcing. And for that we can use the tool called Kerbrute. Of course, I already downloaded the tool and it exists in software. And this is the Kerbrute binary. So let's start the binary like this. And what we are going to do is a user enumeration. So we're going to do user enum. We are going to specify the domain, which is egotisticbank.local. And then we need the word list with usernames we are going to try. And on my behalf, I'm going to use the Xato net 10 million usernames lists, which is part of the security lists or the sec lists. Usernames, Xato net 10 million usernames. And the last thing we need to specify is the domain controller itself. Of course, as we already know, this is 10.10.175. And maybe we want to output this information to a file. So let's put it on the desktop in the Sauna folder. Well, this is not a scan. This is actually, if we find something, this might be loot. And we will call it Kerberos enum users.txt. And or I did something wrong here, or it was very fast. Let me see without this. That's interesting. 10 million user names. Looks like there needs to be an extension there. Right, it is. And then let's try again. This seems to work. And let's see what we find. This might take a little while to complete. So maybe for the sake of the stream, we can look at my backup folder, because of course I already did this box before. And the final output would look something like this. And in the end, we will find a few valid usernames. So let's keep those in mind, or let's copy them to a separate username file. Let's do that. There he goes. He already found the administrator. And then we are going to Sauna, root, and couple usernames. TXT. And let's save this information. So we have a few valid usernames. Interesting to know is we have also an F Smith besides of the H Smith. We also know this is Hugo Smith. We still don't know the first name of F Smith, but at least I think it's his brother. And we have a Sauna user. Now we have some users. We might be able to check a few more things. And another thing we can check is whether ASRep roasting is possible, and ASRep is spelled like this. The term ASRep is derived from the ticket we use in this attack. This is a so-called ASRep ticket. ASRep roasting is all about the do not require Kerberos pre-authentication setting in Active Directory. And before I talk a little bit more about that, let's show that setting. It's actually a very basic setting that is sometimes available on users. When we look at the properties of a user, all the way at the bottom, this is not a default setting, but all the way at the bottom, we see do not require Kerberos pre-authentication. And when this setting is on, we might be able to do some ASRep roasting. So back to Kali. The ASRep ticket is a Kerberos message type which refers to an authentication service, AS, response message. So an authentication service response message. During pre-authentication, the user enters the password, and this password will be used to encrypt the timestamp. The domain controller will then attempt to decode this timestamp, and the domain controller contains the password hash of the user, and thus is able to decrypt this message. And when successful, the correct password has been used, and the domain controller will issue a TGT, a ticket granted ticket, which the user can use for future authentication. This is returned as an AS reply or an ASRep message. If pre-authentication is disabled, then an attacker can actually request this ASRep message without authenticating. A malicious user can then obtain a TGT without knowing the password because authentication is not needed. This TGT can then be cracked offline to obtain the password hash of the user. So let us try some AS-REP roasting. If we would have a Windows machine, we could use Rubius. Then it would look something like this: rubius.exe AS-REP roast. And then usually I want a specific format. That's hashcat. And of course, I want to save the ticket, and I specify that path and name with the outfile flag. But we are currently at a Linux machine. So at Linux, we also have our tools, and we can use the get and pay users script, which is part of Impacket. And let's try that script. We will use Python 3. Of course we will, because Impacket is a collection of Python scripts. And Impacket is at user share doc. There he is. And it's part of the examples directory, but now it's called the get np users.py script. We are going to specify the domain name again. Egotistical bank, local. And now we are going to specify the users file. And we put this on the desktop. Sauna loot usernames.txt. The format we will use is hashcat. If we get something out of this. And we also want an output file. And we are going to set this one also on the desktop. Sauna loot. And well, hashes dot text. And I think I am forgetting something. Yes, it is the domain controller's IP, which is always an important thing to do, like this. And I still have my doubts if the usernames file is correct in the way that we structured it. Go away, you zoom. Right. Well, let's try it like this. If it doesn't work, we will remove the domain name from the username. Domain name should be specified. I think we did that.
I think you need to add the D parameter before the domain. Or not?
That seems like a very good thing to do. Thank you.
You're welcome.
Like this.
Yeah. Or not?
Almost. What am I missing here? What it tells me debug hashes no pass KK is TCP, which we do have. I starting to believe. Oh, that's fun. That we do not need this at all. Let me see if it works. Of course it does not. Oh, this is a bad thing in my demo.
Target.
We need a target, right? And how will we specify that target?
I think you just need to add the IP address at the end again. Because it requires the target at the end. If you see the help message.
Yeah, the help is saying that indeed. And then the domain should be specified. Okay, now we're going back to this one.
Probably need to remove the D then. I think.
That's the thing. When you're starting to doubt, everything is possible. So this is funny.
God.
This is funny.
Someone in the chat is saying perhaps the domain need to be at the end.
Might be, but I think not, because, well, we can try.
Sometimes you use those comments a lot and you still forget the exact parameters.
Yeah, especially when something goes wrong and you're not seeing it, because in my mind everything we need is there. Egotistical bank dot what was it, local this with some quotes.
Oh my.
Unrecognized command. Domain should be okay. I'm not going to stop before this one is fixed, and I can Google for it. Of course, that's something I can do.
I was already checking.
But
okay, so you need to add the domain at the beginning without quotation marks, then the DC IP, then the parameter users file with the file containing the usernames, then the format hashcat, and then at last the output file.
Okay, so you're saying me that DC IP needs to go here.
And then users file, then format. Yeah, that should be, and the domain should be without quotation marks.
Without quotation, maybe that was the error.
Yeah, and they add the slash in the example here at the domain /. No, yeah,
like
at the end of the domain. Yeah, there.
Like this?
Yeah. Yeah.
I cannot remember. I ever did it like this, but it's okay. Cool.
Well,
what we're seeing here is at least we have 4 users where AS rep roasting is not possible. But let's take a look at our output file. We could also use what did we do? Output is in loot, right? Yeah, hashes. Go on. This one. Okay. So down here we are seeing a few entries of F. Smith. There are 4 of them. That's also interesting. Why are there 4? Let me remove the hashes and run the command again, because I think it's weird that there are 4. There are still 4. Okay. Huh. So yeah. Well, we have 4 times the same user with a different hash, which is not bad, because hashing the NTLM hashes use salt and they look different every time. But I think it's a little bit weird that there are 4. Never mind, we can still try to crack them, and we are going to use hashcat to do so. So let's use hashcat, and the module or the mode that we're going to use is 18,200. And And let me see. This is hashcat, so we need the hashes first, like this, and then we're going to specify the user of the word list. That's in user share word list, and then rocku. And because we are using a virtual machine, I have to use the --force because we do not have a graphical card to run the tooling against, which would make it a lot faster. But we do not. This is just a virtual machine.
Perhaps. I don't know if you know it, but Google has some free machines that you can use for cracking. It's called Google Colab, I believe.
Google Core?
Yeah, COLLAB. Yeah, you can.
That's cool.
That's the one I mostly use for cracking with.
Nice. I have to dive into that because that's very interesting. But for now,
yeah, sorry. Someone in the chat just mentioned it. ColabCat. If you Google ColabCat, indeed, then it's nice.
Well, I'm probably not writing it.
I can share you in the chat, in the Zoom chat. I've shared it in the Zoom chat. And yeah, it's good advice from someone who's watching that you should not dox them. They will not be happy if you do that.
Oh, nice. Okay, so I am going to take a look at this one, but not at the moment because running hashcat on my virtual machine for this capture the flag is just fine. It's pretty fast. It already found the password of the hash that we were using, and the password is thestrokes23. So in the end, we have retrieved a valid user and password combination. Now that we have credentials, the attack surface has gotten a lot bigger, and maybe now we can enumerate SMB shares and we can access the existing share without credentials. So to enumerate SMB shares with credentials, I can use, for instance, CrackMapExec. CrackMapExec. And what we want to do is we want to enumerate SMB. And that's the host. We do have a user, and that is F. Smith with the password the strokes23. And the host is then, do I need this? No, this is something we specified on the beginning. We're going to do a local authentication. That's something we need to do. And we are interested in possible shares. We have a status log on failure, so that didn't work. Another tool we might be able to use, which I don't know for myself for a very long time, but I do think it's an interesting tool, is the SMBeagle tool. It's this tooling. Funny thing about this tooling is it starts the enumeration and it creates a list of all the files in all the shares that it finds. So instead of working yourself through the shares, looking what files we have access to, we simply get an output file that tells us all the things and makes it all a little bit faster for enumeration purposes. Maybe we can try SMBeagle. We already know it doesn't work, but it's fun. Let's go to software, SMBeagle, and something like this. But I think this has to be like this. So we will specify an out file for all the things that it finds. We will do a -d. Let me see, the -d is, I thought it was to disable the network scanning, because if I wouldn't specify -d, it would also scan my internal network. At the moment, I do not want that. -u for the user, -p for the password, -h for the host. And maybe you want some verbose output like this. And, well, this is SMBeagle, but still we have no hosts. Okay.
Someone in the chat says, puppies, question mark? Don't know.
Puppies. Well, a beagle is a dog, right? So, well, maybe if it has puppies, are some beautiful ones.
Perhaps Kerberos puppies. 3 heads, small dog.
Kerberos is the three-headed dog from hell, I think. So if that one has puppies, I don't know.
I have also one other question from the audience. Can you please try CrackMapExec without local authentication?
Without local authentication. Like this.
Yeah. That gives a nice error. But it says succeed. But
yeah, so what it's telling me now, it is at least it can authenticate over SMB to the server, but I think there are no shares available for us to enumerate. I'm not pretty sure what the error message says. No section Bloodhound. Talking about hounds again. Maybe something messed up with my installation of Bloodhound, another tool that we will see later on. I don't know. At least it gives an error and it does not return any shares. Local authentication, and maybe that's where I'm mistaken. In my head, I was authenticating to the host that I was providing in the command, but it might also be that local authentication authenticates me to my local machine with the credentials that I'm using on my local machine. So I do not think local authentication is needed in the command. I have to take a look at that as well. But it was like that in my head. Either way, we cannot do anything with SMB. We have credentials, so maybe we can try to log in remotely. We cannot use RDP because port 3389, the normal RDP port, is not open. However, we have not scanned all the ports. We did a normal default Nmap scan, which scans the 1,000 most used ports. So as a double check, let me see if RDP is not open. And we can do it like this. We specify the port. It's filtered, so it's closed. Another thing we can try is WinRM. And if WinRM is open, we can use WinRM to log on. And WinRM listens usually at the default port of 5985. And lucky for us, WinRM is available to us. So we might use WinRM to log in. And to do so, we can use evil WinRM. It's nice that those commands are still in memory. I do not have to type that much. Although, this is a spoiler, we do not want this one. We want to use the user Ffuf with the password, the strokes 23. And that command completed successfully. And we currently have a PowerShell-based session on the machine as the user Ffuf. Yes, we are Ffuf. And we are at the host called Sauna. So that's cool.
One more question from the audience.
Yes.
You never run .pay at your Nmap scan, so you know the P parameter that you give at your Nmap scan. He is asking, you are never doing the -p dash, so scanning all possible ports.
That's correct. We started the machine with a default Nmap scan. So that is indeed why we do not have a visual of all the ports. It didn't try all the ports. It just tried the 1,000 most used ports. So I think WinRM is not in the list of the 1,000 most used ports because we didn't know this port was open. If we would have used the like this, the Nmap -p dash like this, is it like this or like this? I think like this, whatever. But then it would run all the 65,000 and just a few more ports. But the scan would take obviously a lot longer. But you are absolutely correct. We never run that scan, so that's why we didn't know it. Now, well, this is a capture the flag. We have a user login. So as usual, this tab completion doesn't work in evil WinRM. We have a user.txt file on the desktop, meaning we have it the first flag. So let's type user.txt. And this is our first flag. Congratulations to us all. And this is a nice moment to add the flag. Was this hard to do? Well, I don't know. 6. And it's accepted. So let's continue. We have a user session. What do? At first, the first thing to do is to do some basic enumeration. At least that's what I want to do. And for that, we have also a wider range of tools, but the tool that I use most is WinPEAS. It's a Windows machine, so WinPEAS. We also have a LinPEAS, but that's for Linux machines. But I have to get the tool on this machine. So, another thing that I think is interesting is to look at the user folders. This is my user folder. An administrator folder is, well, when we're in there, I think we find the root flag, so we need to get there. But this is also very interesting. We have another user, an SVC loan MGR of a service for a loan manager packet or something like that, but it looks like a service account. Well, this was very easy to spot, so keep that in mind. We are going to use this later on. First, we want to get WinPEAS on here. And to do so, I need to host an HTTP server on my Kali machine. On my desktop, here I have WinPEAS available. So let's start an HTTP server on the desktop so I can download WinPEAS from my machine. And I'm going to use this tab for that because we'll do sudo python 3 -m HTTP server, and we will run the server on port 80.
Someone in the chat is mentioning that WinPEAS will not work if you are no administrator. Is that correct or false?
To my knowledge, that is false. WinPEAS will work, but well, WinPEAS is a tool designed to give you low-hanging fruit information that is currently available to you as the current user. So as an administrator, you get a lot of information, but a lot of those information is actually not necessary, because as an administrator, you have access to all the information on the domain on the computer. So yeah, WinPEAS will tell you that everything is available for you to do privilege escalation. But well, you're already an administrator, so that's not necessary. As a user, when you find something that you can use for privilege escalation, that's interesting. So to my knowledge, WinPEAS is very much usable as a user. But if I'm wrong, please let me know. At least we are going to try to get WinPEAS on here. And let's put it in the documents folder. Users, documents. Oh, well. F. Schmidt, right? Yes. Documents. And since we have an HTTP, let's put it in the documents folder. Users, documents. Oh, well. F. Schmidt, right? Yes. Documents. And since we have an HTTP server running, we can simply use curl, and we can use curl because we are in a PowerShell based prompt. And PowerShell also have curl, which is actually not the real curl, but just a shortcut to the invoke web request command. And my machine, that's interesting. What is my machine? No. This, I am listening on 10.10.14.8. So 10.10.14.8. We want to download WinPEAS x64.exe. I'm going to output this as WinPEAS. Let's make it a bit easier to write. And for this, I'm going to use basic parsing because without the use of basic parsing, Internet Explorer has to be set up and running. This is currently not the case. Well, let's try it without, but probably we get a warning. We did not. Did we download the file? And we downloaded the file. So, well, okay. Basic parsing is not necessary in this occasion. That's fine. We have WinPEAS at our disposal. So simply let's run WinPEAS. WinPEAS.exe. And there he goes. Melvin, I noticed I am already past the hour of talking, and I know you also have something prepared. I think that when I continue doing this box, I will be, well, it will be at least 30 minutes more, which we can expand if we also want to cover the Kerberos topic. So yeah, we can also stop now and continue next time.
Yeah, I don't know what the people who are watching want. The next topic will be talking about basic stack-based buffer overflow. Perhaps for those who are doing OSP or going to do OSP can be handy. Or do you guys want to continue on Active Directory or finish it and start in 25 minutes with stack-based buffer overflow? Let's give them some time to answer.
Yeah, well, that's okay because we have some time for the enumeration, so this was a good timing. Well, as you can already see, WinPEAS is putting a lot of information on the screen, and WinPEAS is done. Well, we can do this on two ways. We could also have output the information of WinPEAS to an external file, so we can analyze that file on our own machine. But I usually just scroll up, and now I have to use my mouse wheel to do so, so it takes longer because I've lost my scroll bar.
It seems the people are okay if you continue for 20 minutes.
Yeah, okay. So, and there are a lot of ports. I wish, well, let me see if I can, yeah, this is better. Some network information. Let me go all the way to the start of WinPEAS. We are not going to look at every detail WinPEAS is giving us, but we are nearly at the top. So WinPEAS gives us a lot of basic information. We have some information about local users, an administrator, guest, Kerberos TGT user, H Smith, F Smith, and the SVC loan manager is enabled. So that's good to know. Of course, we have all the access to F Smith, but the most interesting information we can find in this enumeration is this part. We found some auto login credentials. So we found the user. Well, we could have guessed this one, SVC loan manager, with the password money makes the world go round. Cool. Let me copy this. Oh, come on. When I move my mouse cursor to the top, the zoom bar goes down, and well, it's pretty annoying. But just for our information, let's save this part. And we can find a lot more information, like it's a 64-bit machine. We are currently a member of the remote management users. There is no password policy activated or enforced, and the firewall is currently enabled. Well, that's all of the information that we can get out of this. But let's take a look at the AutoLogon credentials. We can also find these credentials in the registry because that's where WinPEAS found it. And I think we can use ref.exe to do so. If we would query the key, and that's the local machine HKLM. Software, I thought it was software. Microsoft. Tab completion would be nice. Windows NT. And I'm doubting if it's with a, I think it's with a space like this. And the current version. And finally, WinLogon. This is where the AutoLogon credentials are stored. And as you can see, we can also manually get this out of the registry. Money makes the world go round. But again, we have new credentials. So let's try those credentials, and let's try them like we did before with WinRM. Let's make this a bit bigger, clear things up. Use evil WinRM, evil WinRM. And now we can use this one with money makes the world go round as a password. And when we do, we have a session as the SVC loan manager. So that's interesting. We are currently the second user on this box. Now, at this moment, we can try to run some new enumeration with WinPEAS, but that would not reveal new information we can use. So let's check if we are a member of a specific non-default group. And we can do that simply with who are my groups. And the thing that stands out is this one. We are a member of the remote management users, and all the other groups seems like they are default. But maybe the remote management users group is an interesting group, but we don't know. To know that, we want to have a better understanding of the relationships between the Active Directory objects. So let's do a scan of the Active Directory domain. Perhaps there are certain Active Directory settings in place that we can use to our advantage. A well-known tool for doing this is Bloodhound. And the ingester or the collector that creates Bloodhound-ready JSON files is Sharphound. Let's run Sharphound under the loan manager account. And we can also do this from the fsmith account, but in this case, both scans will reveal just about the same information. So just do it like the loan manager user. And again, we will use curl to get the Sharphound ingester. So we are going to use curl with HTTP. And I thought I was working on 14.8 like this. Sharphound is with a capital H.exe. Like this. Do we have? Yes, we do have Sharphound. Nice. So let's run Sharphound. And we will specify the collection methods. It has several, as we can see with -a, h. We have several collection methods, but I want to use all of them. I want to collect everything. So I'm going to use collection methods all. Dash collection methods all. And Sharphound is running. This might take a minute to complete. And what we get once the scan is done, we will get a zip file, because that's what Sharphound does. Sharphound creates a bunch of JSON files, a JSON file for the computers it finds, for the users it finds, etc. And it will put them all in a zip file, so we can easily transfer the zip file to our own machine and then analyze the files in Bloodhound. Maybe we can start an SMB server to transfer the zip file back to us, because I can pull files with HTTP, but I cannot get them back on my machine. And that's exactly what I want at this moment. I want the zip file to be on my machine, but it's a Windows machine and SMB is available. So what we will do, we will spin up our own SMB server, and we will make a connection from the remote machine to our own machine to transfer the file. Let's use this tab as well to start the SMB server. And we're going to do that with the SMB server.py script, which is also part of InPacket. You can use a Python 3 with user share. Yeah, this is okay. We will start the SMB server.py. Our share is called share, and it is not what I want, because I want the share to be connected to my desktop and not to my root. So like this. With the dot, we will specify the desktop as the share, and we will use SMB2 support. We need SMB2 support because SMB1 is not available anymore at newer machines. So when we do this, config files are parsed and my SMB server is running. So that's good to know. And at the moment, Sharphound is done. And as you can see, we have a nice zip file. And to make things a little bit easier, I want the pop-up gone. Thank you. So let's rename the item. This. And I want to give it a new name, like loanmgr.zip. Cool, that works. And now we can simply copy loanmgr.zip to 10.10.14.8, and my share was called share, so like this. And if I'm not mistaken, as we can see in the log of the SMB server, a connection is made and files are being transmitted. Looks like that's done. Let me see. And if I'm not mistaken, we have a loan manager zip file. Cool. So now we can start Bloodhound and analyze the file. I just downloaded Bloodhound and I don't know where I put it. I thought it was in software Bloodhound. Seems like something I would use. Yeah, it is. Cool. So let's start Bloodhound with no sandbox. It has no connection to the Neo4j server because we obviously need to start that first. But The dropout of Zoom is blocking my way to the terminal. Yes, cool. So let's first do a sudo start sudo neo4j start. And once that's done, we will start Bloodhound again. We were too quick. There may be a short delay until the server is ready, but I guess that's the case. And now it succeeds. Cool. What we will do, we will clear the database of any data that's in there at the moment. So we will start with a clean slate. And then the most easy way to put the files in is simply drag and drop the zip file in there. Everything is done. So let's refresh the database statistics. And we see we have information about 6 users, 53 groups, 1 computer, etc. When we now try default queries, because default queries are in the analysis part of Bloodhound, we can try, if we can find some interesting information. Let's see, what can we do here? The first thing I usually do is I will mark the credentials that I have as pound. So let's do that as first. We have F Smith, this user, right click and mark user as owned. And we also have the SVC loan manager. Let me display the labels so it's easier to see with who we are working. We will mark this one as owned as well. And what we might be able to do is the shortest path from owned credentials, the shortest path to domain admins from owned credentials. Let's try if we can find some interesting information in this one. We cannot. Shortest path maybe from the loan manager. Okay. The SVC loan manager can do a PS remote to the server. And under normal circumstances, this would be interesting information because this would mean we can do a PowerShell command, or PowerShell connection to the remote server. But at this moment, we also have a PowerShell connection with our WinRM connection. So, well, although this might be interesting, it's not for us at the moment. To get some more interesting information, we will take a look at the users themselves. Because if we click on the user and we go to the node information, we will have a lot of statistics about this specific user. And one important part of information are the outbound control rights. What kind of rights do I have as the SVC loan manager user on other objects outside of myself? And when we click this one, we will see something interesting. We have a get changes all and a get changes right. Now, what can we do with these? This is those settings that Bloodhound gives us is because the user has the get changes and get changes all. Let me show you this in the lab. Like this. I think it makes it a little bit easier. We take a look at the properties of the domain. And we will take a look at security. We'll have a few security settings for the domain available. Well, someone who has the get changes all has the rights to modify the domain. And when we do have the rights to modify the domain, so I can give everyone the full control would obviously trigger it, but also giving it read and write and create triggers the get changes all. But when we have those security settings in place, it means we can do something with the domain. And in our case, we might be able to run a DCSync operation. And DCSync is normally a process that domain controllers initiate between themselves to synchronize Active Directory information so all domain controllers are in sync. So if we can start the DCSync process, we can also capture the output of that process. And this way we can get all the usernames and associated hashes. We can run the DCSync locally with Mimikatz and several other tools, but we can also do this remotely when we have access to the service SMB ports, 135 and 445, and the RPC ports. And since we have access, we can also run the DCSync process from our Kali machine with the Secretsdump script. And needless to say, it's also from InPacket. Let me drop this down. Fingers crossed I can get to my terminal. Yes, we can. Thank you, Zoom. And let's run the DCSync script. Am I going to create a new tab? Oh, yes, I am. Let me think. Secretsdump is also Python 3. It's InPacket. So it's in the examples folder of InPacket. But this one is called Secretsdump. And thank you for giving me the option to finish my command without typing. We are going to run Secretsdump as the SVC load manager with the password at 10.10.10.175. And this gives us all the information of the users in the domain and all the hashes that belong to those users. So let me grab this output. DCSync hashes.txt like this. Let's save this one. And what I want to do again is to crack those with hashcat. One thing we need to do is to clean those hashes up. We only need the NTLM part of the hash, so we only need this part.
But what if you cannot crack the hash?
What if we cannot crack the hash? Then we have to do some further enumeration, I guess, because I do have the get changes all right on the domain, so we might be able to force that right to do something else. Maybe Bloodhound gives that information as well.
There's a different attack that you can do with only the hash.
You mean pass the hash?
Yeah.
Yes. Of course we can pass the hash. That's well. Let me. Pass the hash was part of my second part of this box actually, because I wanted to do a few more things, passing the hash and Kerberos thing. So yeah. Let's first try to clean my hashes file up and crack it with hashcat. And back. Thank you. Now we need to clean up the file. So let's get the DCSync hashes.txt. Use the cut tool to cut away some information. And as a delimiter, we're going to choose the double point. And we want to keep the fourth field. And we are going to output this to whatever, clean DCSync hashes. Did that work? Almost, because this one shouldn't be there. Let's remove that one as well pretty quickly, like this. And now we have the clean hashes. We can again try to crack them with hashcat. I think most, yeah, well, this is nice.
Can we crack it in 4 minutes?
If we crack it in 4 minutes. Yeah, let me do my best to do that.
More power.
We call this clean hashes. Let's continue. But okay, spoiler. I was trying to run with you through the normal process I would do, and the first thing I would try to do is to crack the hash. And now you're getting to the point that I wanted to tell you about. Now we are going to pass the hash. Simple as that. Because, well, we do not have the option to crack it. And we can pass the hash again with a lot of tools, and one of those tools is again the evil winrm tool. So if we will do evil winrm, and we will now use the administrator user. We will use -h for the hash. So instead of a password, we simply pass the administrator's hash. And voila, we are an administrator on the box. App complete, command doesn't work. Oh, come on. And this would give us the final root flag of the machine. So, I had another thing prepared where we could have gone from here. We could have gained graphical access like with remote desktop connection. So we have a visual on how Active Directory was configured on this machine. And then we could force the creation of a service account to show you some Kerberos. But at this moment, looking at the time, I think that's not the right time to do so. I will keep this one in mind for maybe the next session. As a final part, I will tell them that I will have owned the root, submit the flag, and as far as I'm concerned for this session, we are done with this box. So Melvin, it's my honor to give the mic back to you.
Yeah, thank you. Yeah, this was the session of Jarno. So yeah, for those who are watching, still watching, yeah, given how do you say it in English? Applaudience to
Yes.
Yeah. And now the real hacking starts. No. No, yeah. Now we are going to start with stack-based buffer overflow. So let me switch to my screen. Going to move this one here. And move this one here. And you see still that annoying thing here. Okay, so you can see my screen. If I'm right.
Yes.
Yeah, my apologies for the Windows XP. Please don't ask me why, but yeah, as you can see, it's very slow, but okay. So we are going to abuse an executable called ftp server.x. Now, I've already a skeleton exploit. I'm always using skeleton exploits, just contains the basic code you need. Skeleton code is a small piece of code that you can always reuse for every buffer overflow you do, stack-based, structured exception handling overflow. As you can see, we are sending 1000 times the character A. We're making connection to the target. Now we are sending a user, anonymous, password, anonymous. And when it asks for the host, that's where we will use the buffer, the 1000 A's. And yeah, then it should crash. So that's what we're going to do as the first step to search if we can crash this beautiful application. I'm using Immunity Debugger, as you can see. But there are more options. There are also WinDBG, and there's also something called HackDBG, I believe, or PwnDBG. It's more advanced. So as you can see, let me start the application. Okay, the application should run at this moment. Let me go back to the application, the code. And let me change this to the target. It's important. Okay, so this is what we are going to do at the first step. Exploit development. Okay. Always forget if it's Python. Yeah, okay, it's Python 2. Exploit completed, so the application should crash. And voila, as you can see, access violation. And as you can see, we have some pointers. Now you can see the most important extended extraction pointer, the AEP, the ASP, the top of the stack. The ASP is always pointing to the top of the stack. The EBP, the bottom of the stack, so it's mostly to the bottom, is always a pointer that is referencing, if I can say correct, referencing to the stack. But we are focusing on the first one, the extended extraction pointer. As that is the one that we need to take control over, to let the execution flow change to a different part in the memory area. So yeah, we just confirmed that after 1000 bytes, we just confirmed that after 1000 bytes we crashed the application, but we don't know where, when, what's the exact offset when this application crashes. So that's why we are going to calculate the next step. And there are different ways to do this. I'm always using the Metasploit pattern create script, but Immunity Debugger also as a plugin, I believe, MonaPy create pattern. Hope it works, and of course it's not working because I need to import the module. But okay, we are not going to do that right now because of the time. So I'm using the Metasploit framework one. You specify the length that you want, and then enter 1000. Now you get some weird random string that you are going to add in your exploit. So let me comment this out and let me paste it. Okay. Okay, so we are going to restart this program. Restart. Yes. Yeah, you can also use Pwn tools. Okay, program is running and we are firing our exploits again. And what we can see our weird string. But what is special is this instruction pointer that is pointing to some weird random character. So we need to calculate the exact offset. Yeah, there's a handy script for that too. That's offset. You specify the length, but you don't really need to specify the length. And then need to type 694, 694, 694, 1232, 1232, 69. And we have found the exact offset. That's 247. So let's just confirm that this is real, that it is not a false positive. So that's what we're going to do the next part. Okay, so then we are adding 4 times b to just check if you can override the instruction pointer. And then, yeah. Mean length buffer. Okay. As you know, we started with 1000 bytes, so I always prefer to extract the total amount, mean the rest of the buffer, and fill it with garbage. C in this case. Okay, let me restart the program again. Yeah, this is the only downside. You always need to restart the program 1000 times. Okay, then we run and we have a connection refused. Did I forget to run it? Oh wait, no, it is running. the exploit has been fired. And you can clearly see that the instruction pointer is pointing to 424242, which is the B in ASCII. So that's great. We have confirmed that this offset is right. And now the next thing to do is the most difficult part for stack-based buffer flow is to find the jump ESP. As someone already mentioned in the chat, we need to find a valid jump ESP. Yeah, Mona has some amazing built-in script to do this, but as I already saw, Monetpy is not imported, so let me import it. I don't know why it's not imported, by the way, but can I find it? Oh my god.
Back to the 80s.
Yeah, back to the 80s. I don't know why it's not important, but it should be. Yeah, back to the 80s indeed. Well, yeah, anyway. I can spin up my... Oh, your exploit. Files admin. Desktop. Yeah, this sucks. I don't know why it's PyCommands error importing module. Seems like...
Weird.
Oh, I'm sure it does not have Windows Debugger, of course. Oh my god, this is really old school. Long time ago I did all files and folders. All part of the file name, WinDBG. There's our puppies.
Well, it's probably not there, I would guess. No, it's not. Is the Mona script available in the what was it, PyCommands folder?
Yeah, it should be available. I have solutions. No, I don't want solutions, but doesn't. No, okay, pattern. Nope. Immunity debugger, yeah. Normal UFO. Python. Wasm installer, FF10. It's always nice when you Python. Perhaps it is in the Python folder.
I think it's in the immunity folder itself. In program files, I think.
Yeah, but I'm not allowed to.
Oh, well.
Yeah, show contents of this folder. Oh wait, no, yeah. Ah, okay, this is base. Immunity bugger, yes, where are you?
Immunity Inc.
Yeah, there it is. Immunity bugger. It should be in PyCommands. And Mona, yeah, it says. Oh wait, of course. Oh my god, if this is correct. Ah, fuck. Sorry. There it is. You don't need to specify .py as I has been used in the past, but okay, you can see clearly all the commands available if you can run Mona. So you can now create the pattern create, and I specify. Oh, here is the pattern. You can see. So you can also create the pattern with Mona. It's just your prefer, what you prefer above the other. But let's find jump ESP. So let me check jump ESP. It's sowieso find, I believe it's jump ASP. Just checking my notes. It's obvious. Oh yeah. Before we of course can find valid jump ASP, it's important to load all modules. Because you can of course randomly search for jump ASP, but it's important to check the protections in place. Well, in this case, it's not really matter because all of them are mostly false. But in the case of, for example, structured exception handler overflow that we are going to do next session, this safe structured exception handler protection is really important. If it is true, yeah, you can totally forget about the structured exception handler buffer overflow. So in this case, it's false, so mostly you are fine. But okay, let's go back to the stack-based overflow. We are looking for something that is 4 times false or 5 times, and there's only one thing that has this, and that's the executable itself. So we can search for jump ASP inside this module, and it's important to know the opcodes for jump ASP. So we can let me check NASM shell. Okay, wat was het? NASM. Yeah, NASM. Yeah, okay, no idea why it doesn't work. Normally it does, but okay, let me start NASM shell. With NASM shell you can convert instructions to opcodes that you can then use, for example, in mona.py to search for specific instructions like jump ESP. Oh yeah, of course, I can increase the font size. Okay, let me first do this. So jump ASP, and you can clearly see that the instructions we are looking for is FFE4. That's the thing we are looking for. So let's go back. Someone is asking me to make this bigger. Appearance, font. Okay, I hope this is better. It's for me much better. Okay, so we are having the opcodes. Now I need to find the instruction. Okay, here it is. So you can do find as, always start with X, A4, and then the name of the module. So we are going to do, yeah, it's a weird name, server.eggs. Found a total of null pointers. Amazing. It's really amazing. Found null pointers. So it tells me now that there are no jump ASPs, which is weird because it should be always, but or it can't find the module. That's also possible. Oh yeah, it's a looking different module. Weird. Let me try a different module, but yeah, it's important that this OSDL is false. So there's only one option, but okay, let me try a different one. Let me do, which one is not Windows default? Since this one are all default. This one is, let me just do the top one. ADV API, I know it is, okay, it has found a total of 5 pointers in this case. At this address, those 5 addresses, there is a valid jump ASP. Let me just try one, see if we can hit it. So this will be the jump ASP. Import struct. I'm probably okay. Let me check. I always forget this comment. It's much easier to use the struct library in Python because you can do the following if I found it. Of course not. Exit. Cd exploit. Okay, let me check. Get Python. Get Windows. Type is Overflow. Yeah, it's always. No, you can also do it without. Let's just do it without. There's a Python module struct that you can easily use for this case. You can normally when you need to add an address like we are doing right now, you need to think about little endian. So you need to turn it around. But with the struct module or library, you don't need to do that. You can just place the exact address as it is in the code. So no need to convert it back, but yeah, it's not a problem either way. So let me check. Day 3. Day 9. Day 9. Day 9. A2. A2, and 7. And why it is red, I don't know. But okay, probably the wrong. Okay, so this is the JMP ESP. It should be the different hash, but okay. Now let's see what is happening if we send this. At this moment, can I go back? Okay. Yeah. Let's restart. Let's set a breakpoint at this address. Yeah. Import struct pack, and yeah, I know there's further struct exploit. I know there's an easy. Normally you will find those examples easily on internet, but always when you are in the hurry. Oh wait, here do I have? Yeah, struct pack indeed. Struct pack. Okay, let me first try this, then we will do struct pack. But okay. Set a breakpoint at this address. Okay. It was stupid for me to not write down the address, but okay. No x77 A2 D9 D3. Let me just place it here. So BP. Okay, I hope it placed the breakpoint. Run program. Access violation, so it doesn't hit. Yeah, it doesn't hit our JMP ESP, so probably this address is definitely wrong. Normally I had thousands of examples for this, but it's much easier indeed to do it that way. So just struct pack. This it is indeed, yes. Import struct, yes. So now we can. Yeah, I made one horrible mistake. That is to not write down the address that we
I'm sorry for putting a time delay on it, for giving you less time. Because these are usually the kind of errors you're going to make when you have less time.
Yeah. Oh. Okay, that's really annoying of Unity debugger. If you double click the field, it's gone, so I need to write it down here. So this no x 7782 7782 7782 D9 D3. So this is the address. So let me just copy paste, put it here. So this is much easier. And now it's important to close this one. Let me restart it. Yes. Double click this. Okay. BP. I have no idea if it plays a breakpoint, but I'm used to Windows debugger. So I need to get used to this long time ago. Okay, Python exploit. Yes. Yeah, you can see we hit the breakpoint, so we are now at the jump ASP. So if I continue with this, we should jump to our C's. So, okay, let me continue. Step into, I believe. Step into. And you can clearly see that we are in our C's. So we are nearly there. And we still have time, so... yeah, the next thing is important too, because if I place my shellcode right now, right here where we are at this instruction, it will not work. Or it perhaps work if you are lucky, but most of the time it will not work, because you need to do something else before, and that is adding a knob slide. In assembly you have a character or an instruction that is this one, and what it does is literally nothing. It's just a knob, no operation. And what we are going to do is adding a knob slide. So let me introduce that right here, right after we jump ASP to the next position. So x90, x90, oh yeah, x90. Or there's a different instruction that's called int3, and that's not really similar to the knob, but yeah, for debugging it's better to use the int3 instruction, because the int3 instruction will also stop the execution at that part. So if you are debugging like what we are doing now, it's better to use int3, so you can just let the execution continue, and when it hits the int3 it stops. And with the knob operation it just continues, so you have no idea if it is going correctly or not. So what we're going to do is, again, how much shall we do? 20, let me do 20. Okay, so we have 20, we have 247 times A, then we have the jump ASP, then we have the knob slide, and then we will land in our C's. That's the idea. So let me restart. Let me also place the breakpoint again, because it's nice to know everything works according to plan. Okay, continue. And then we can just continue. And we are again at the breakpoint, so let me jump into. And you can see that we are indeed having 20 times knobs, as you can also see right here. Knob, and then we are at the C's. I have no idea why it's doing SOR, but yeah, SOR, and then two instructions SOR AX will be 0, but okay. Yes, int3 is like a breakpoint. I mostly use int3 to place somewhere in my code to know that when it is there, it will just breaks the execution, so I know, okay, yes, we are there now in the shellcodes. Especially when you are doing shellcoding, believe me, you will love int3.
And when the debugger stops at int3, you can still continue the operation?
Yes, when you hit an int3, for example, I can show you. It will just tell me here we hit a breakpoint, and then I need to press this button again to let it continue. Let me place it. Let me just place one int3 right here before. So int3. Let me just do one time. Okay, I have going to restart it, not placing any breakpoint, and it should break. Okay, run it. Yeah, you can see that it. Oh yeah, it says access violation. But yeah, it is normally a breakpoint. I don't know why this GS short is here. But
okay.
Normally it should say here below breakpoint hit, and I can just press this button and it will continue.
Cool.
I can show you an example, but it's...
Well, let's not get too off topic right now.
Yeah, I cannot also share it because of people who are not really happy. But yeah, that's the idea of an int3. It's just, yeah, something like a breakpoint. But let's continue indeed, because of the timing. I see that many people are leaving. Probably because it's late. Okay, so... Okay, we are having the jump ASP, we have the knob slide. So the last part, or not really the last part, but next to the last part is finding bad characters. It will be really horrible if there's a bad character and you are trying to activate your shellcode and there's a character that is perhaps messing your shellcode that you cannot run it, that it will crash the program. So we need to find bad characters. We can do that the following. Let me check. I'm always using this GitHub repository to just grab it. To grab the bad characters. Let me grab it. Okay, let me place it right here. Bad chars. Okay, bad chars. Let me add bad chars right here. But I think our bad... okay, let me see if that will work. But so we are going to jump ASP. Then knob slide. Let me decrease the knob slide to a little bit less. 20 is a little bit much. And then we will see the bad characters. Okay, let me... debug restart. Let me also set the breakpoint again, so we can follow our execution flow. Okay, now we have hit the breakpoint. So if I continue, step into, and you can clearly see no one. Oh, wait. Here it is. Here. You can see right here. I hope you guys can see it from there. But you can see no 1, no 3, no 3, no 3, no 4, no 5, no 6, no 7, no 8. So you can clearly see. And then after no 9, there's something really weird going on. Then it suddenly jumps to 27, which is weird. Should not do that. So there's a high chance that the one after no 9 is a bad character. So this one is probably a bad character, and that is most of the times this is indeed a bad character because it is an if I'm correct, it is a new line, but I'm always putting this down. Bad characters, bad characters. Okay, so we're removing the A and then we fire it again. And yes, this is really no. Yes, this is really a boring part of exploit development. Repeating, repeating, and repeating till you find all bad characters. Okay, so we're removing the A and then we fire it again. And yes, this is really a no. Yes, this is really a boring part of exploit development. Repeating, repeating, and repeating till you find all bad characters.
Most tedious process while doing a buffer overflow. Absolutely.
Yeah, that's the only downside indeed to repeat this process. So we're running it again, we hit our breakpoint, we step through it, and we can again see 1, 3, and you can clearly see that 27 is gone. So the next one is 0B, which is correct. Then we have 0C, and then we again have the 27. So probably after 0C, there's again a bad character. So let me remove that one too. That's this one. So let me remove that one. Okay. Yes, it is possible to automate this. I think everything is possible to automate eventually. But yeah, I think you can easily automate this, but yeah, I don't know. I always did it manually. I'm no good Python developer.
If somebody knows how to automate this, I would be very interested in that.
You're welcome to hit me up indeed. Okay, so we are again at 10. Now you can clearly see no B, no C, no D, no E, no F, 10, 11. And you can clearly see that it now seems to be correct. So if we follow it, we can see that all characters now are, or wait, 30. Oh wait, yeah, 30. 2A, 2B, 2C, 30, 31, yeah. We can clearly see it's weird that sometimes it starts at the right, sometimes at the left, but okay. Yes, it seems if you go down, check 50, 60, 70, 80, 90. Okay, where we should end at the FF part. Yes, here is the FF. So it seems that these are the only characters. So we have found all the bad characters. Now there are only 2, I believe, out of my head. 2, so those 2. So now it's time for the final part, the most fun part. And the most stressful part, if it doesn't work at the end, is generate shellcode, place it here, get a reverse shell, and done. Okay, let me check. Okay, Windows reverse TPS, lhost, tunnel 0. Oh shit, it's the wrong one. No, okay, wrong button. Oh shit, it is tab 0. L port. No. Exit function is thread. Oh, I see that I already had the entire comment for me. Sometimes it is really nice. Oh wait, it's not the red corrector. It is 0D and 0A indeed. 0AF Python. Okay. This can take some time. And there it is. You can, by the way, if you can see buff. You can rename buff to something else. But I forgot the parameter. Yeah, it's amazing. But there's a possibility that you can, you need to specify one parameter, and you can change this buffer. So for example, if you have your code and you have, for example, shellcode, and you want to add the exploit to your variable shellcode, you can change just the name from buff to shellcode with MS Venom. That is possible. I think it is. I have it in my notes, but for now it's not really. I will come back to it next time if you guys help me remember, because I will totally forget it. Okay, let me place the shellcodes below right here. Okay, you can see it's always a nice habit to place the comment you used for the shellcode above the shellcode. So you can, if you forget and you continue later what shellcode you used, you can always check here. Okay, so we have everything correct. So we need to remove the bad jars. Then we need to add the buff. I think it's even bigger than 1000 bytes. Or the total page is 67. Okay, perhaps we are lucky and we get it. So next part is starting MSV console and preparing our reverse shell. Yeah, it happens me a lot of times that I made my code and it was really late and I was like, oh man, I'm going to continue tomorrow. And then the next day I came back and I was like, interesting. Which shell did I use? Because I was forgetting this year. So I was like, okay, no idea. Let's find it out again. So yeah, it's a lot of work again. Yeah, you can already see it was HTTPS. Yeah, HTTPS, okay. Set port. Set lhost. No. Exploit EA. Okay, session created. Great. We have saved this. We have restarted this. So it's now the moment of truth. Live or die. I hope I am able to live again. Let me set a breakpoint. Just to be sure, we hit it again. Okay, the exploit is not crashing, which is good. We hit our breakpoint, which is good. We jump, which is good. You can see our knobs. 10 knobs indeed, and then you can see the start of our shellcode right here. Those are the instructions. So if I continue, we will see if we get in session or not. Not much happening right now. Perhaps there's one thing that I can think of why this is not working, and that is 64-bit or 32-bit application. Because if you're using 64-bit shellcode on a 32-bit application, then of course it will not work. So I need to change the shellcode again. And I think that is the case. Because the program is running. It's not crashing. Yeah, the program is running. So I think it's indeed I need to specify a 32-bit application. So let's just generate the same exploit, but then for... I always forget. Oh wait. I am already using 32-bit. I think I need to specify the 64-bit. Do I still have shell? No, I have no shell. I think it's 64-bit. Let me just try it. Let me kill this session. Jobs, kill, kill. Okay. Set payload Windows x64 interpreter reverse. Oh wait. Reverse FTPS exploit. Yay. Okay. As you can see, it's already a lot. Oh no, it's not much bigger. Great. Okay, copy selection. Let me paste it here. Place it right here. Change it. In case it's the same exploit. Okay. Debug. Restart. Restart. Placing the breakpoint. Breakpoint. Starting the application. Firing the exploit. Access violation hit. I placed the breakpoint, right? Or it is 32-bit. We have a JMP ESP, so you can clearly see knobs. And then our shellcode. Yeah.
Yeah, it should. Well, it's Windows XP, so it should be 32-bit, I think.
Yeah, so the first time it should have.
Yeah.
But perhaps I'm missing. Yeah, I'm already seeing what I'm doing totally wrong. Yeah, I had to do that. Then it should be 32-bit indeed. No idea why the first time it didn't work, but perhaps this is the case because I forgot slash. Yeah. Oh, where does it say? Someone mentioned it about 32-bit somewhere top here?
Yes, top right.
I see cross. Top right. I cannot see 32-bit in Immunity Debugger. It will be nice if they add it. Top right bane. AS. Top right bane. Here? Walk and talk took forever, missed all of the buffer overflow. Top right bane, AS0320. Oh, hier. Ah, hier, yeah, 32-bit, 20. Yeah, okay, yeah. Yeah, okay. It says 32-bit. Nice. Did it. Never looked at that one, but okay, nice. Thank you. Learned something too.
Cool.
Okay, be that. Let's hope it will now work. Okay, let's place it right here. Okay, we have the. Just be sure, we have the 247 A's, we have the JMP ESP, we have the knob slide, then we increase the knob slide to 30, we have the buffer, the shellcode, and then the filler, or the garbage. Okay, let me restart. It should now definitely work. The exploit is listening, right? Oh wait. Jobs kill 0, jobs kill 1, set exploit. Windows interpreter reverse, and I'm already exploit. Yay, okay. Place a breakpoint, yep, and start. And sending the exploit, okay. Yes, we hit our breakpoint. JMP ESP, we continue. And okay, this looks much better. Now you can clearly see that it is a knob.
Yeah.
That looks much better. So if I now continue, then it should work. Okay, it still says run program, but...
Fast?
It should work, but it still crash. It says here D9. Don't know how to bypass comment that is try to change AEP or pass exception to program.
I know the command.
This is really weird. We have a JMP ESP, we are doing everything correct. We have removed the bad characters. Oh, wait. God damn it. God. How can I forget that? The most important bad character there ever is. 0 byte, of course.
0 byte? Oh no.
Oh my god. Yeah. It's always the number 1 byte you 99% out of 100 in exploit environment. You remove this 0 byte. Stupid that I didn't think about it. Let me add it there. Okay. Yes. Debug, restart. Okay, set me breakpoint again. Let me fire it. Okay, and did we add breakpoint at? Yes. Nop. Fire. Okay, this looks much better. But still, it doesn't want to spawn my shell.
What?
Why? It does grep function. What grep function? It doesn't say crashes or something. But you all, normally when it works, you can see that it is importing a lot of DLs, but now it doesn't. This took 2-bit, right?
Yeah, it has to be.
Yeah. Now perhaps in bind shell, I can try and bind shell perhaps, which is weird because yeah, why shouldn't reverse shell? Let me do something different. Yeah. You can see show options. If config on and you can see here it is listening.
Tab 0, yeah.
Yeah, it's correct. Let me try a different thing. Let me try. If this works, then it's perhaps some firewall settings at. Let me pop a calc. Let me see if that works. We do not need our host and the entire riddle. Just need this. Oh wait, we can do an exit function thread that we can keep. Okay. If calculator spawns, then we know that we have indeed the possibility to run commands, and we should have the possibility to run a reverse shell. As you can see, the size of this payload compared to the one that we had here above.
Much smaller.
Yeah. Okay, let me. Okay, so we have a calculator. FT seems to be right. Okay, debug. I really hope it pops a calculator. It's a NH proof for me. Breakpoint set. Perhaps I can do it without the breakpoint. Perhaps that's the problem. But sending the exploit. Okay, we have the breakpoint. Step into it. Nop. And I don't see any calculator. So there's still something wrong. Access violation writing to access file. This is weird. What am I? Okay, we are going to a JMP. That seems all correct. We are having the knobs, seems correct. And we have the shellcode. So what is wrong at this? Am I forgetting bad character perhaps? No. Oh. Should it? No, I don't think that must matter. Slash. I don't think there's really. I don't see any null byte in this payload here, so I think. Let me see if there's any difference. I don't see the point in. Is it different? No, it's exactly the same payload size. And I don't see any bad characters in this payload. That's not the problem. We have aligned the stack indeed, as you can see. We have 30 knobs. Oh, let me specify it. No slide. Look at the last chart, different. Yeah, of course there are some difference. We can try it, but I don't think it will really matter that much. But yeah. As I say, trial and error is your best friend.
Yeah, but it takes so much time. That's the thing.
Yeah. We have 10 minutes. Ah, yeah, kijk, we have a calculator, so I have no idea if it indeed was the slash that perhaps did this trick, but we have our calculator, so it works. So the next step and the final step, I hope, is the reverse shell. So let me get back to this one. Let me shift the slashes to the other side. It's in 32 bits, port 9000, top 0, Python D, okay. Nope. And it will be funny. Is there a job running? Okay, there's a job running. Great. And we have our big, huge payload again. It's no puppy, but it is really the hellhound. Okay, I'm not going to place any breakpoints because, yeah, we already know we hit the breakpoint, so yeah, no point in keep doing it. Just want to get the reverse shell. That's all. And we are setting our exploit. And do we get it? Yes, we get our reverse shell. Because you can clearly see at the bottom left that it is loading all our DLs that we need to get the shell. And if I go back, we have our shell. I hope. Why?
Yes.
Well, it's not giving.
Very. I thought it was there.
Yeah. It showed me that it is loading all the DLs that is required to pop the shell, but somehow it is not doing anything at this moment. Oh wait. Oh. Sessions? Ugh. It's really weird.
No sessions. Oh, come on.
Okay. I'm going to do one more thing and then I really don't know. Let's do the old school TCP shell instead of the HTTPS perhaps. Can be a problem with defender blocking or the firewall blocking. I have no idea. I don't know how they... But then of course I need to stop this job again. Set payload Windows interpreter TCP. Okay. Exploit. Yay. Oh, it's also much smaller than HTTPS. Perhaps that's the case. Perhaps this one is just too big and somehow, yeah, I don't know, it doesn't fit correctly, or it's.
Yeah, maybe your buffer is too small.
Yeah. Yeah, that's something for the next lesson. What happens if your buffer is too small? Indeed, what can you do then? Then our famous equator will come into play.
Yeah, we will not talk about hounds. We will talk about eggs.
Eastern bunny. Yeah, there's our shell. You can see sending stage. Now it's our shell. Oh wait, extra validation. Serious?
Yeah.
What now? Oh wait, there. No, still sending. God damn it. It really doesn't. Oh wait, we have a session, but can I Yeah, we have a session. Oh no, oh not. Now somehow it connects and then it dies. It's amazing. Windows XP is really fascinating. I think we need to implement Windows XP to all companies. Then we are safe for every.
Super safe, yeah.
Just doesn't work.
Maybe non-staged, might be.
Yeah, perhaps non-staged indeed.
Will be a lot bigger, that's true.
I believe it is this one, right? I always use this, but yeah, it's this one. If that doesn't work, then there's only one option, and that is a bind shell. That will be the last option, that we just open a port on the target. Oh, huh? Windows. I always forget Windows, reverse. Is it shell TCP perhaps? Reverse shell TCP?
Do you want to have an interpreter or not?
No, let's just do netcat. I think it's much easier. Oh, it's also not working. Or is it? Is the reverse TCP?
It's shell underscore reverse.
Oh
right?
my god.
And then I think underscore TCP, but whatever.
I always forget those different names.
Yeah, me as well.
It should be much easier if they stick to some naming convention. Yeah, I know they do, but they explain in OCP clearly. Windows shell, yeah, okay, I have that one. Yeah, okay, here it is. If this doesn't work, then I don't know. Oh. Ooh. Then I'm going to eat my shoe. I have no shoes here, so you can't tell me to show it. I have no shoes here. Okay, this is the one. Restart. Oh wait. Need an. It's 9,000. 9,000. Oh wait, we have of course. Exit. Jobs kill 3. Okay, listening, debug, restart, and let the demo gods be here for once. Yeah. What? Okay, yes, we have a reverse shell. Finally. But somehow I cannot do who am I. No idea. Is who am I? Did it exist in Windows XP?
Yes, it did. Can you do a simple CD or dir?
Who am I is not recognized as an term. What the? Yeah, dir is working, but who am I is not.
No, come on. Is it not there? Alright.
No. Okay, I think who am I came later.
Yeah.
Okay, that's something I didn't knew.
No.
Nice. But we have a reverse show, guys. So yeah, this was the session about stack-based buffer flow. It was a little bit longer than I expected because of all those shells. Somehow the HTTPS shell didn't work, but the TCP shell did work. But it didn't make a connection to the interpreter shell. But a normal netcat listener and a normal shell without interpreter did work. So yeah, so let me summarize the exploit. We started with finding the offset, that is 247. Then with mona.py we found the jump ESP address, that is this address. If you remember, you can mona modules, and you find all modules, check which one are false and true. Important are the first 4 need to be false, the last one can be true, but prefer to be false. Then we did this command, jump ESP. We found 5 jump ESP addresses. Now you can pick up any one you like, paste it here. Then we added a knob slide. Then we added our shellcode, which is a normal shell, really important. Normal shell, no interpreter please. And then, yeah, something to fill the garbage, the filler. And we have a shell. So, so we have a shell. So yeah, I think this was the first session from me and Jarno. And the next one will be in about 4 weeks. Every first Monday of the month, I believe.
Yeah, that's what we what we were brainstorming about. So it's fine by me.
Yeah, it's fine by me too.
Cool.
I think everyone liked today's session. There were a lot of people watching, so I think it was a nice session. Oh, wait, before everyone is leaving, this is especially for the Dutch people. Yeah, if you live close to Netherlands, you can also come. There's an event. Me and Jarno and some other couple of guys are creating this. It will be the first year this year, but our plan is to do it every year. But this will be the first year. It is called hackthevilla.nl, and the idea is to be there buying a luxury villa with 8 to 12 people this year. If it will be a success, then we will increase by next year. But let's see how this year will go. We will be there with a guy with a lot of guys, ladies who love hacking, and there will be food, pizza, ClubMate. If the hackers are familiar with ClubMate, it's especially drink for. Yeah, they drink it normally with hack events. I don't know. I don't really like it, but that's my opinion.
It's gross as shit, as far as I'm concerned.
Yeah.
But okay.
Oh yeah, sorry. We are renting the villa, not buying it. I'm not that rich to buy it, but perhaps we can ask Elon Musk to support us. He has plenty of money. But yeah, if you are interested in joining us for this event this year, we have no specific date yet, as it is still in the baby shoes. You are welcome to join. We are still having place available. We are with 7 guys now, so you can still come if you like.
How can they make it known, Melvin, that they would like to come? Discord?
Oh yeah, we have a Discord channel. Let me send you the invite. Hang on a moment, my computer is not really fast. I need to buy a new one. You can join this Discord. It is only meant to talk about this event and the date, and any suggestions are welcome. If you have any idea to make it better, bigger, I don't know, just put it there and we can think about it. There's also another Villa event in the Netherlands with a lot of bug bounty hunters, but I'm not the one who's organizing that, so I cannot tell you a lot about that one. But if you are interested, please join our Discord, and we hope we see you there. So that was the last part for me. If Jarno has anything to say, perhaps you can say.
No, not actually. I really like doing today's stream. I will thank everybody for watching, for the great comments. Still learning every day, learning from your comments, learning from Melvin. So it was a great experience, and absolutely, let's do this again.
Yeah, as Jarno said, thank you for watching, and I really hope you enjoyed it today. It was a long stream, and I wish everyone a nice evening, and whatever you are going to do next after this, sleeping, hacking, whatever, have fun, enjoy, and take care, and see you all next month.
Thank you so much, everybody.
Bye bye, everyone.